Now we're going to look at the sum of an arithmetic sequence, which is also called an arithmetic series. Often in applications, we'll want the sum of a certain number of terms in an arithmetic sequence. The story is told of a grade school teacher in the 1700s that wanted to keep her class busy while she graded papers, so she asked them to add up all of the numbers from 1 to 100. These numbers are an arithmetic sequence with common difference 1. Carl Friedrich Gauss, who went on to become a very famous mathematician, was in the class and had the answer in a minute or two. Remember, no calculators in those days. This is what he did. He noticed that pairs of numbers added up to 101. 1 plus 100 was 101, 2 plus 99 is 101, 3 plus 98, 4 plus 97, etc. With 100 numbers, there are 50 pairs that add up to 101, so 50 times 101 is 5,050. This will always work with an arithmetic sequence. So the formula for the sum of n terms is just what Carl Friedrich Gauss did. A sub 1 plus a sub n is the first term plus the last term. So you add those up and figure out what that is, that sum is. And then n over 2 is the number of terms divided by 2, or the number of pairs of terms. So you say, I take this n over 2 is the number of pairs of terms times the first term plus the last term, which is the value of each pair. And I should have waited and done this first because it said all that. So let's find the sum of 1 plus 5, 3 plus 5 plus ... all the way up to plus 59. But how many terms are there? We can write a formula for the sequence and then figure out what term number 59 is. Okay, so notice that we have a sub 1 is 1, a sub n is 59, but we don't know n here. Okay, so here's what we know. We know that the common difference is 2. It's an arithmetic sequence. We know the first term and the last term. We're trying to find this sum. So here's what we know. We don't know n. So let's use a sub 1 equals 1 and d equals 2 to write the explicit formula for the sequence. So a sub n equals 1 plus n minus 1 times 2, or using simplifying that, a sub n equals 2n minus 1. Now, 59 is a sub n. That's what we're trying to find. We want to know the n that goes with 59. So we're going to substitute 59 for a sub n and solve it for n, and we get n is 30. So now we know that there are 30 terms. And we can put 30 in for n, 1 plus 59. So we are finding the sum of 30 terms, or 15 pairs, of the quantity 60. That's the end of our how to find a geometric sum. Pretty easy.